Hello and welcome to the next video in our series of videos about maze algorithms and how to create mazes. So in the first two videos we've looked at how to create a maze and then how to draw it. If you haven't watched those videos yet, then it's probably recommended that you do so before continuing with this one, because it does set the scene as to how to create the maze, how that algorithm works, and then how to draw it. Okay, so once you've drawn your maze, then you might want to find out a little bit about it. And one of the key measures really is to calculate the distances between different squares in a maze. So when you're thinking about finding a solved path or a path through a maze, then you want to know the distance between any given pair of cells in the grid. So we might want to know how far apart, for instance, if this is our start square at the top left, how far apart it is from the square at the top right. And this is a 20 by 20 maze, and we've set the start and end square as 1 and 20 arbitrarily, but you could run this algorithm starting from any square. But let's start at the top left square, and let's ask ourselves, how do we calculate how far away all the other squares in the grid are from this top left square? Now the good news is you can use a very simple algorithm to do that. So we pick our starting point here. This is the top left square, and we would mark that with the number 0, because in terms of calculating the distance from that square to any other, then that square is 0 squares away from itself. And then all we do is we look at all connected neighbors to that square. Now here there's only one connected neighbor because there's a wall south. So we look at each connected neighbor, that's just this square in this instance, and we mark each of those squares as 1 further away. So 0 plus 1 is 1. So this square would then be marked as 1. And then we simply repeat. That's all you do. It's a really simple algorithm. So now you repeat from all the squares 1 away from this one. Well, that's only 1 square in this instance. But let's say we were at this square here, square 4. So there'd now be 2 squares 1 away from it. And so for each of those squares, we'd mark them as 1 away. And then we just repeat and repeat and repeat the process. Find a square, mark it as 1 further away than you're currently at, then look at all the connected neighbors that have not yet been visited by the algorithm, and then mark them as 1 further away. Then for each of those neighbors, you find all of their neighbors that have not yet been visited by the algorithm, and then mark them all as 1 further away. And you simply repeat for each square that is connected to our squares. We mark 1 further away that is not yet visited until you've marked every single square in the grid. So what does that look like? So let's click show distances and we'll find out. So we now have the distance from this square for every single square in the grid. These are just in light blue because we've marked them as the start and end points. So if this were the endpoint of the grid, we now know that we need to make 217 steps to reach it from our start square. And you can see how this kind of ripples out. So our first decision point is here. In a sense, that's the first point in this maze where we have a choice whether we go left or right. Until then, it's forced. And then we come round, and there's another decision point. And then we simply can see that the path winds round and round the grid, visiting all the different squares and marking them as 1 further away until we come all the way around and we'd reach the solution square here. Okay, so that's how to find the path between any 2 points in our perfect maze using this very simple algorithm. So to recap, we pick our start cell, we mark it as 0, we find all the unvisited neighbors that are connected to that square, we mark them 1, then we find all the connected neighbors from the squares that were 1 away, and we mark them 2, then we find all the neighbors for the square that were 2 away that have not yet been visited, and we mark them 3, and so on, and so on, and so on, until we've visited every square. And then we can simply display the distance value in each square. Okay, so that's how to calculate distances in a maze. In the next video, we will use this information to find a solution path, which will obviously be very useful if we're actually creating a real maze that we want to give somebody to solve. Hope you found this video useful. If you did, then please do like the video and subscribe to our channel It only takes a second and it really helps support us. And as ever, thanks for watching and goodbye.